Question 8. A man stands on a wooden board to paint a wall. As shown in diagram 1, the diagram shows some of the forces acting. When I look at the question, and there is another force here, which is the weight of the man while standing on the wooden board. And the examiner given us two values of distances, and there is a kind of a reference point here. You might say this is the kind of my reference point. I'm going to calculate a new concept in physics, or you might be familiar, which is moment. Moment here, or the principle of moment for the statement, is the clockwise moment, you have to say, around the pivot. So I can choose, this one is my reference here, which is the pivot, equals to the anti-clockwise moment around pivot as well. Is that enough to get 1 mark? Yes. You might go for F1 times D1, distance 1, equals to F2 times D2. One side is clockwise and the other side is the anti-clockwise one. Calculate the force X when and ignore the weight of the wooden board. So I have to ask myself, how can I calculate the force? Firstly, use the section I in double I. Moment is what? It's a force times distance from pivot, or perpendicular distance from pivot. Okay, apply the principle itself, which is F1 times D1 equals to F2 times D2. How many forces? We have 2 forces and 2 distances. So force X, which is unknown, so I would say F as an X times the distance 1. You go up here and you see where is the pivot here, and I have to take in consideration the perpendicular distance from the applied force here, which is X, makes 90 degree horizontal distance from pivot. So F of X times the whole distance here, which is 2 distances, it's 0.6 and 1.4. So times 1.4 plus 0.6 equals the weight causing, it's clockwise if I made a mistake, and force X, which is counter or anti-clockwise. Okay, let's go to the equation again. So 620, and the perpendicular distance from pivot here, which is 1.4 meter. So 620 times 1.4. Okay, is that enough to get 4 marks? I think you should rearrange the equation. So f of x equals to 620 times 1.4 divided by 1.4 plus 1.6, which is 2.0 as meter. The correct answer for the force, which is f of x, the man walks to the other end of the wooden board, as shown in the diagram, in diagram 2. Okay, so this is the direction of movement. The man goes from right side to the left side. The examiner now is asking, explain the change in force X as the man walks along the wooden board. Back again to the same concept of the principle of moment. My question is, the wooden board is still in equilibrium position? Yes. So my point is to maintain, you would say, equilibrium. What should I get? I know, sir, it's the clockwise moment must be equal to anti-clockwise, moment. C is anti-clockwise, C is clockwise moment and equals to the anti-clockwise moment. Hopefully you're not confusing. So let me draw the applied force again. So this is the force, which is F of X. And here we're from the center of mass of the man, which is the weight. Just to remind you, this is the clockwise, and the green one, which is the applied force, is anti-clockwise moment. The man now, there is no problem, I think, in the equation. We just go normally to substitute as we did before. The clockwise moment, which is the weight of the man, so W of the man times the distance between the man and the pivot, equals to the applied force, which is F of x, times the distance between the force, which is x, and the pivot, force x and pivot. Okay, I'm moving step by step. We did not finish the completing the answer yet. We're moving step by step. I know the weight is constant, okay, but what did I do? The distance between the man, or the line of action of the weight, and the pivot now decreases. Okay, so this is very important keyword, and the examiner, he said, explain. So you should say the distance between the line of action of the weight is between the distance between, the line of action of the force or the weight of the man and the pivot decreases. Then what happened to the other side? Do you think there is a change in the position or the line of action of the force X with the pivot? No, there is no change. So at the other side, this one is constant as well. Any change happened, whatever decreases or increases at the left side, so directly you have to see the same change at the other side to maintain equilibrium or balance, the kind of equality. So the value of this force must be decreases as well, because the weight of the man is moving away from the right side, or the support, or so the force Fx is going to be less. So this, I think we get 3 marks, but it's preferable to show that the examiner that the clockwise moment and anti-clockwise moment, they are equal, and you have to write them down and say that the force F is X is going to be less because the perpendicular distance between the weight of the man and the pivot decreases. And do not forget to mention maintaining equilibrium. Hopefully you understand this concept. It's very unique for a physicist to get full mark in a moment. It's not easy concept, my sons and daughters. See you next video.